Hello everyone, my name is Matt. I'm the physical therapist and the founder of the Aging Gracefully platform and the 8-week class. So this is the build log, a look under the hood of how AG102.com actually gets made. This section had two halves, a deep dive research onto the standing calf raise and a round of unglamorous housekeeping. Both came back to the same premise that the numbers you see in the app and the ones you see in class are the ones that actually you can trust. And let's get into it. We didn't start from zero. We picked up mid stride with two things on the table. One was a deep dive on the calf raise. You raise up on your toes over and over until your calf gives out. And that tells you a lot about your lower leg endurance, and the other was housekeeping, the boring cleanup that keeps a hand-built project from rooting underneath you. And the one rule I kept coming back to all session, the working code and the actual published studies are the truth. Every planning note I wrote is just a draft, and drafts drift. So when a note and the code disagrees, I trust the code and fix the note, never the other way around. It sounds obvious, but the most expensive mistakes come from trusting a confident-looking note no one else double checks. Here's a moment I'm proudest of, and it's a mistake we didn't make. Several of my own planning notes said the calf raise norm scores came from a 2023 study. Sounded fine, but the rule is check the original before you trust your note. So that's what we did. And that 2023 paper wasn't actually a scoring table at all. It was a small study with 132 people building a prediction formula. The real data, the 566 person data set, the numbers actually trace back to, come to a completely different paper from 2017. The 2023 study is still useful in providing the test works. It's just not where the norms live. If I trust my note, every calf score the platform ever showed would have cited the wrong study. A quiet error baked in forever. Catching it costs 2 minutes. 2 minutes against a permanent mistake. That's a whole case for checking your sources. So how will this test actually work? The published data is all single leg. So single leg is the version we scored against. And almost every rule in the protocol exists to protect the honesty of your number. The metronome ticks the screen at 60 beats a minute because if you go faster, you can pile up reps that don't actually mean anything. You rise up to a marked height every time, and we stop counting when that range drops. So the reps means the same thing for you as it does for everyone else. And for the research, you can rest a fingertip on a wall for balance, but that's the moment you push off from your arm, that rep does not count. And we want you to have a slight incline to match the science. If you go to a flat instead, the app will tell you straight up that your number won't match the table. None of it's fussy. Each rule closes a door on the score could sneak out of. Single leg is hard, so most people will start with 2 legs. We'll track that 2-leg version so you can watch for yourself and improve, but we will not score it against the published norms because honestly, those numbers do not exist for 2-leg tests. Comparing you to a standard nobody studied would just be made up. Once you can do about 20 clean 2-legged calf raises, we'll start moving you to 1 leg. With a bridge, you can shift more and more weight on one side until you stand on it alone. Here's the key. That bridge is training. We reward you for practicing it, but it didn't touch your score because I cannot precisely measure the weight shift without a lab gear. We can guess your score, rewarding that effort. Reward effort only that measurements we can actually stand behind move your number. The calf raise is one about 60 measures we have to work through. So this session I also locked down the process because doing 60 of these by improving is exactly how errors sneak in. Every measure runs the same 4 stages. Research and decide, that is the conversation, then document it in the reference files, then sync it so the next starts from a clean file. Then separately build the scoring into the live app. We do 3 at a time. We drop to 2 when one turns out to be a beast, like the calf raise did, when a quick add became a whole progression ladder, and the build rules are strict, 1 fix per commit. Look how much you touch before the change before it ships. Boring and repeatable. It's what the error rate from creeping in when you're doing it solo. Now some plumbing, the unglamorous kind that quietly causes bugs. Our master reference document used to be put its versions right in the name. Reference 9, reference 10, looks tidy, but every time that number changes, every linking pointing to that old name broke, and we've been limping along with stale broken links because of that exactly thing. So we fixed it for good. The file name never changes again. The version now lives inside of a document, and the clean history log built right in. Adding a small thing like a calf raise bumps a decimal. Only a big redesign bumps a full number. And the system already remembers the complete history no matter what the file is changed. 1 careful rename with every link repaired in the same step, retrying the whole recurring headache. 3 things actually shipped this time, and I want to show you them, because in building out loud, the housekeeping matters as much as the features. First, our master measurement checklist went from a clunky spreadsheet into a clean text file the assistant can edit precisely. Second, that reference document went versionless, so we repaired every stale internal link in the very same step, and so the project was never broken for a moment. Third, we merged 2 competing versions into 1 log. Each of these was its own careful commit, review before it went live, and confirm on the main branch before we moved on. No flashy new features today, but a foundation everything else stands on gets noticeably more honest. From a solo build, that's a generally good day. So what's next? We're moving to the heart and lung tests. The big one, VO2 max, the most oxygen our body can use when you're working hard. It matters more than any other single number because it tracks better than most things. How many active independent years you have left ahead of you. Your marginal decade. It's a heavy lift because everything else feeds into it. The two copper running test gets converted into a VO2 max estimate first, then scored through one of the shared engine, and building in the same way. Also fixes a bug where a couple of cardio tests are being scored backwards. These running tests are tough. They are marked advanced, and most of you will stick with the walking versions, but the fitter folks will have them. We'll get VO2 max right first, and everything downstream inherits the solid foundation. Now an update, because what happened next is the best illustration of the whole process. We sat down to finish the cardio batch, and a quick recheck of the calf raise turned into a main event. By the end, we had it all locked all the way down to the math, real source and real scoring formula, and just as important, an honest accounting of where everything and the formula edges are. Here's how we did it and how it unfolded. It actually started as a cardio session. We shipped 2 cardio fixes first. We swapped the mile-and-a-half running test out for a better formula, the George 1993 equation, which adjusts for body weight and sex, so it's more accurate for older adults. And we enriched the VO2 max norms with a much bigger data set, nearly 8,000 people each went on its own commit. Then I want to do a quick recheck of the calf raise, just confirming what it already handled, and that the quick check turned into a whole rest of the session. Along the way, 2 things looked broken and scared me. A file that seemed changed and a timestamp that looked stale. Both were noise. The lesson: when something looks broken, check Git, not the file manager. Here's what's reading the actual repo turned up, and it's why the check the code first rule keeps earning its keep. 3 findings. 1. There was no strength entry for the heel raise at all. There was a balance test that used a similar posture, but the endurance measure itself, no, not in the repo. 2. No build log. Nothing was written down on how to score it. And 3. The tracker had a dangling pointer, a little note that said about 566 people, Tapanya 2023, ? Confirmed, pointing at data in the project never actually had. So the gap was real, and now it's filled. With the right paper locked in, Hébert-Losier 2017, a confident look note had been aiming at something that wasn't there. Once we had the right paper, it turned out to be plenty strong to score against. We know exactly how strong. 566 adults, ages 20 to 81. The test reliability is excellent. Basically, the test someone twice and you get almost the same number. The measurement error is about 2 reps either way. Median performance is around 24 reps on the right leg and 23 reps on the left. And here's something more interesting. Men do more reps than women up until about 860, and then the women catch up and pull ahead. That's a real pattern in the data, not a fluke. So the scoring keeps it instead of averaging it away, and why we score men and women against their own curves. Now, how did we turn that study into a score? The easy way would be a lookup table, find your age and sex box, read the normal number, but that is coarse and it is blind to things that will actually change with the result. The paper gives us something much better, a formula that calculates your personal expected reps from your age, sex, BMI, and your activity level, with that separate equation for each leg, because a left and right behave a little differently. So instead of dropping you into a generic bucket, we compute a norm that actually is yours. The cost is that we need one extra piece of information from you, how active you are. And it turns out that to be the most important input of all. Okay, here's the actual math, and don't worry, you don't have to do any of it. The app does it all. There's one equation for your left leg and a different equation for your right, and they're never blended together. Each takes your age, sex, and the way the age and sex interact, your BMI, and your activity level, and produces your expected number of reps for that leg. The reason I trust these formulas isn't that they look impressive, it's that the paper published 2 working examples, real people with known answers. So the test is simple when our code spits out the same as the paper did. We know how they built it, and if it doesn't match, we don't ship it. And that's the whole standard. Match the source or it doesn't go live. There's one new thing we have to ask you for your activity level, and it's not a vague question. The formula is built around Pacific six-level scale designed for older adults that runs from hardly any activity at level 1 to a hard exerciser several times a week at level 6. We have to use the exact scale, not a similar version, or the math does not line up. Here's why I love this input. It matters more than your age. The differences between the least active and the most active person is something like 7 to 9 reps, bigger than the effect on your years, which means the thing that moves your score the most is one thing you actually control. Move more, and your expected range climbs right along with you. Now, here's where we have to be honest about a limitation. A study measures activity levels 2 through 6, but not level 1. The most sedentary, there's no published number for it. We had two choices: invent a penalty the research never measured, or use the closest real number we have. We chose the honest one. We held we hold level 1 to level 2 value, a conservative floor, and then we tell you that we did that. You get measured, and it says, in fact, your estimate is based on the nearest activity research activity level. So treat it as a starting line, not a verdict. And here's the encouraging part. Activity is the single biggest factor in this test, more than age. So you're starting at sedentary, you have the most room to gain of anyone. Let's build it from there. Because the two legs behave differently, we score them separately. Your left against the left norm and your right against the right norm. And we watch the gap between them. If one leg beats the other by more than 3 reps, we raise a flag. Because of a gap that big can mean a meaningful difference worth looking into. A weaker side, gait issue, even a fall risk. But here's the important part. That flag never lowers your score. It's information for follow-up, not a penalty. And we set the threshold above the test's own margin of error, so it doesn't cry wolf. Finally, we're honest about the edges. It's the valid for certain ages, for certain BMIs, and activity levels 2 through 6. Stepping out of that, instead of pretending, the app tells you you're outside of the valid range. So what actually happens next and in what order? It splits it into stage A right now is documentation only. We write the new source into the reference, fix the tracker now, retire the wrong citation, no code touches the live app yet. Stage B later is the real build, capturing your activity level, wiring the two-leg scoring engine as asymmetry flag and a safety guards. Each of those an own clean commit, each test in the browser, and here's the rule that keeps me honest. Research being done is not the same as features being done. The test stays open on the board until the live website actually changes. Decide, then document, then build. And only when it's live, it gets called finished. That's the session. One wrong citation caught before it shipped. A calf raise protocol locked, and all the ways down to the math, with the honest edges named out loud, and the foundation solid enough to build 60 more measurements on. That is what we're building in public looks like up close, one trustworthy number at a time. Thank you for watching. All right, we're going to combine the cardio repair as well because they're kind of interconnected, since we had that aspect where I was going into the cardio and found the calf raise bug. So Here we begin the cardio aspects, and it's supposed to be kind of an update, and it turns out to be a lot different. So this is going to be an update for this. So this part starts out easy. The job was check what our cardio fizz test was, the running test, the walking test, the one that estimate VO2 max, which is basically your aerobic engine size. Check what they're scoring people currently, and then wire them into the dashboard. And I had planning notes to tell me exactly what went wrong. There was supposed to be an inversion bug. One test was flagged as current misscored, so I could have just gone and fixed in the note said, but there was a rule I had held on this project. The code is the truth. Planning docs are guessing, and about the code, the guessing drift. So instead of trusting my own notes, I had the code actual read before touching anything. And one decision is why this turned into a real lesson instead of a quick task.
So I did the recon, actually read the live code twice independently, and the code contradicted the docs almost point for point. The note said broken funnel, needs rebuild, inversion bug, dead wiring, misscored test. The code said the funnel already is here. The best of logic that picks the most reliable fitness estimate already here. Both the scoring tables, the walking test, the 12-minute run, all present, all scoring correctly. Two separate passes, same answer. That's the scary thing. That's scary. It's all broken. Framing was just stale. All of the repair. I braced myself, for I had already been done at the same point. Somebody who just went back and crossed off the list. And that's exactly why we read the code before you touch it. If I trusted the notes, I would have gone rebuilding things that were not broken. So 3 of the 4 cardio measures were just fine, already corrected, already wired up. If you enter the VO2 max directly, it passes right through, and you get the most trusted number. The 12-minute run test uses a formula that looked weird. There's a minus 50.9 and divided 49 in 3. But when you are working in algebra, it's exactly the standard textbook equation. It's correct. It just looks odd. And we in the walking test, full conversion, it wired correctly, it labels match, and misscored none, note, stale. And then the discipline, which is much harder than it sounds. Leave it alone when you're psyched yourself up for a repair, and then this itches to fix something. But fixing an equation because it looks strange, or renaming labels that already match. That's just how you break something that's working already. So what was actually broken? One thing. The mile-and-a-half run test was using old, cruder formula to estimate VO2 max. Basically, just your time noted else. We're swapping it out for a better one. The Georgia equation from 1993, which validated for adults and unfolded in body weight and your sex, not just how fast you ran. It's more accurate for an actual person. And the next part, we already collected some of the weight and sex elsewhere, so this asks nothing new. Now notice one small thing on the screen, the formula male and female as 1 and female as 0. Hold that thought because it's become revealing in a couple slides, but a change this is a better equation, swapping for three spots in the code. Now, this is future self-talking. We actually went back and did the research a little bit more, and this equation was actually built for college-age students, so we actually have to redo this. But that's a conversation for a future self. Now, how you make that one change matters. as much as the change itself, because this is live. Editing a feature no one uses yet is easy. If it breaks, no harm. But if the edit members already see the dashboard, getting it wrong, you've corrupted the person's scores in real time. So it gets three guardrails. One, the formula actually lives in three places: the main code, a copy in the calculator, and the on-screen text that prints it out. And all three changes in one commit, so the code never contradicts itself. Two, we check it on both screens because the course page on the dashboard runs differently on changing right on one, but it can be wrong on the other. Three, the careful rhythm. Stop, review the exact diff, one change at a time, whether it's one line or 100 lines, because how big of change looks tells you nothing about how much damage it can do. Okay, here's a trap hiding inside one simple fix, and it's a good one to learn from. The formula codes your sex as a number. Fine, except they don't agree on which number means male. The George equation says male is 1. The leg strength formula we used says male is 0. The walking test says male is 1 again. So if I plug it in the wrong conversion, nothing breaks. No error, no crash. It just quietly biases every score for one entire sex, all in the same direction, and no one notices. For the app, those who point its trustworthy results, the silent kind of wrong is the worst kind there is. So we can confirm the convention everywhere. The formula gets used, and we put a gate in front of the commit. A known example: a 45-year-old woman and a 55 running a distance of 13.5 minutes should come out around 39, and the faster time has to have a higher score. If either one's off, the unit or the sex sign is wrong, we stop. The gate catches the big mistake, but the sex sign itself, we need to humanize, because a silent bias is the most expensive bug you can ship. Nothing ever tells you it's there. Beyond that one real fix, the deep dive turned into 3 optional upgrades, none of them to repair. Of all of them insurance. The first, there were actually 2 separate rating tables. One of them, the course page, and the other one, the dashboard. So we aligned them so we can never see good on one screen and a different one on another. Second, there's a spot where a single walking test can get counted twice and quietly breaks the take your best result rule. So making sure it counted only once. Third, there are 0 automated tests on the cardio scoring right now. None. So we added them, feed them to a known input, check for the known correct answer for every conversion. None of the fixes anything that broke today. It makes a stuff that's right harder to accidentally break tomorrow. That's the kind of work no one sees until it saves you. All right, the loose end on all of this aspects. So we're going through this, and I look back at the documentation to figure out if it still says it's broken, and it does. So why does it say miss a out of date? The track and references are still calling it broken, even though we did the 2 recon passes and just disproved it. So we need to have to do something quietly here, because it's quietly breaking. It's not telling you it's doing this, and it's taking. So I have to do something that is not the funnest, but it's more bookkeeping. Figuring out when we change and work on something, it has to automatically prompt code to update the documents that we're working through to help track progress along the way. If we don't do that, we're just going to keep working through and it's going to keep looking stale. So that's something that we have to do a detour from. So, because everything's working how we intended it to be, except we set up all these checks and balances, except they are not actually getting crossed off when we are completing the task.
So before we move from the deep dives, I did the boring, responsible thing. I stopped and asked, is the reference I'm working with the actual up to date? And what should the 10-second check turn genuine usefully into a detour? Because the file looks stale, and when something looks stale, your instinct is the sync broke, the upload failed, something's out of date. But when the instinct sent me crushing a problem that wasn't actually there, what was it actually doing? There was two different things, both hiding behind the same symptom, honesty. Both are the same kind of trap we fooled anyone building solo. So let me walk through what fooled us, because you'll hit the same thing. First trap, the date at the top of the file. It said last updated June 17th, and I believe it. Why wouldn't I? But here's the thing. The date had been frozen since the day I file has been created. Meanwhile, the actual content set has been edited over and over, including good current work from the session. So the file was lying about its own age. The rows were fresh, the date was stale, and the stale date is worse than no date at all, because it doesn't just fail, it informs you it is failing. It actually misleads you into thinking everything below it is old too. So we made a rule. If the document has a last updated line, you bump it to the same commit you change something else, no exceptions, because the date that lies about the file will send you chasing problems that don't exist, which is exactly what it did to me. Second trap, and the smarter, sneakier one. There is a row that said one of the cardio tests was current misscored, and I looked at it and thought, see, stale, that has been corrected, except it hadn't been, when it actually traced that, so the document wasn't out of date at all. It was accurately reflecting reality. The fix is still pending, and the general link import destination, because my copy is behind the source, and the source itself hadn't been fixed yet, are two completely different problems. And if you confuse them, you go fixing the wrong thing. The correction now bundled into cardio build. So the same commit that fixes the wording will bump the stubborn date to two birds with one. So how does it end? Honestly, pretty undramatic. There was no clever bug, no heroic fix. The whole thing came down to a habit. Keep your documents honest about their own state, and test your assumptions before you act on them, including your assumptions about your own tools. If it looks stale, is it the is not the same thing as it is stale. I am telling those apart saved me from fixing things that weren't broken. What came out of this one small rule, if a file had a date on it, you bumped that date on the same commit, you changed it to anything. But if something's building this solo, those little guardrails are everything. Every one of those is a future distraction I don't have to deal with, which means more attention left for the stuff that actually matters. And that's a good note to close on. A deep dive section, and the science has to be right, but so does the boring habits underneath them.